All right, hello everybody. This is Mr. Munson. We're in Unit 3, Parallel Lines and Transversals. I like this section a lot because, first of all, it's very quick and easy. The concepts are not too hard to get. Now, there's some memorization that you have to do, but if you do it right and think it right and listen to my advice, this is probably going to be one of the easiest units we do all year. We're going to be looking at complicated looking figures like the one below, but we're going to learn how to manage and get the information from that we want. Let's move on. So let's first start with this. We're going to be doing vocabulary, and as you can see, there's a URL code there. If you were to copy that or type it into a browser, you'll get a link to you'll go to a page that is basically this vocabulary sheet. Okay, and so you can just simply print that up and write in the information and have the vocabulary sheet all ready to go. Okay, so go ahead and put me on pause, go find that vocabulary sheet, or you're welcome to draw out and print out your own on your own piece of paper, writing the lines and all that stuff here. Okay, so the first up is linear pair. We've had this before. Two adjacent angles with one pair of opposite rays. And I've kind of abbreviated opposite there. We've got an example there in the picture. And 1 and 2 are linear pair. Measure of angle 1 and the measure of angle 2 are 180 degrees. That's old news. Let's move. Okay, vertical angles, two angles that have a pair of opposite rays. So if you take a look at angle 1 and 2, angle 1 is created by the rays that are in blue, angle 2 is created by the rays in green, and those are vertical angles. Old stuff. I'm just hoping for those people who are still kind of struggling with that idea, we just solidified it for them. Let's move on. All right, intersecting lines. Two lines that intersect when they share a common point. So here's a blue line and a red line with a point. Very basic stuff. Now remember, I'm moving through these pretty quickly, but the beautiful thing is you can put me on pause, go back and review it, write down what you need to, and stay with me. Here we go, transversal. A transversal is a line that intersects two or more lines. So the green line in this picture would be called a transversal because it touches two different lines, the blue one and the two blue ones. Let's move on. All right, next up are exterior angles formed by a transversal. So angles formed outside of the two lines intersected by the transversal. Those are called exterior angles. Angles formed on the outside. So if you take a look at my drawing over here, the blue angles are exterior angles because they're on the outside. They're not in between the two lines. They're on the outside, right? So there's some examples of exterior angles. All right, for me, it makes sense if there's exterior angles, there's interior angles. Angles formed inside of two lines intersected by a transversal. So as you can see, they're inside the two lines cut by the transversal. So those make them interior angles. So there's 4 pair in there. All right, let's move on. So here we have the next one is alternate exterior angles. So these are definitely exterior angles. Alternate's kind of the new word added to the word exterior angles. Basically, two exterior angles on opposite sides of the transversals. Okay, so now if you look at angle 1 and angle 2, they're definitely exterior angles and on opposite sides of the transversal. That's no doubt. But we already have a special name for that. Those are two pair of linear pair angles. Okay, those are a linear pair. So we're not talking about that. We're talking about, in this case, another type of set of special angles. So what I want to point you to is this. We're going to be looking at a set of one angle from this intersection, 1, 2, 3, 4, and this one down here, and creating a pair. So one from the top, one from the bottom, that represent an alternate exterior angle. Okay, pair. So in this case, 1 and 7 are alternate exterior angles. They're both exterior angles, 1 and 7 are, and they're both on opposite sides of the transversal. That's what makes them alternate exterior angles. Okay, 2 and 8 meet that same criteria. All right, alternate interior angles would be two interior angles on opposite sides of the transversal. That totally makes sense to me. So here we are with, again, the same drawing, 1, 2, 3, 4. And so the blue angles are alternate because they're on different sides of the transversal, and they're interior angles. It makes real simple sense, I hope, to you. Let's move on to the next set. Next up, we have consecutive interior angles, and that's two interior angles on the same side of the transversal. So if you take a look at this drawing, we have two angles, and they're both on this side of the transversal, and those are called consecutive interior angles. And over here on the side, blue angles, right? So I have those written in as our examples. Let's move on. All right, I know that the drawing there has a lot of stuff going on, so let's just talk about it real quick. We have corresponding angles. Corresponding angles. Two angles in corresponding positions relative to the two lines cut by the transversal. Okay, so we have two lines, that green line and that line, cut by the red transversal. And so what ends up happening is if you look up at the top here, there's an intersection that creates angles 1, 2, 3, 4, excuse me. So angle 1 is sitting at the top left-hand side of those four angles. So if you now look down at the bottom set of angles and say to yourself, which angle sits at the top left corner? That'd be angle 5. And so 1 and 5 are what we would call corresponding angles. They sit in relatively the same position as we look at this set of corresponding angles. Okay. 2 and 6 are the same. Can you think of the angle that would correspond to angle 3? So hopefully you looked down and found angle 7. How about angle 4? Could you find this corresponding angle that goes with 4? And I'm hoping that you said 8, and if you did, you've got it. Otherwise, rewind me and try to make sure you understand that concept. All right, the next thing on your list there is slope of a line, but we're going to hold off on that concept or that thought until we get to concept number 2. So we're done with vocabulary for now. Now we're going to look at some special problem. So here you are. We have two lines cut by transversal and the angles that are formed by it. And so one of the I can statements that you have to do for this concept is I can identify special angle relationships. Okay, so great. Put me on pause, and I want you to look at the angles that I've chosen over to the right, and right next to it, write down the name from our vocabulary that is the words that go along with that set of angles, okay? Think that through. If you just skip this part and you don't put me on pause, I guarantee you're going to struggle, and that's a setup. You don't want to do that. Let's be a champion. Just put me on pause. Let's go back and look at your vocabulary and see if you can figure out what it is. All right, those hopefully are the ones you came up with. Now let's see if we can just do some real quick analysis on this much more complicated picture. So if I was asking you, what is the corresponding angle in for number 2 that is down in this area, you should be able to identify which angle goes to that number 2. Did you say, whoops, did you say 6? Hopefully. All right, so now a little bit more complicated. Let's look at angle number 2 and ask yourself in this set down here, which one is the corresponding angle? And it's 11. Okay, so if you think about it, 9 goes with 4, 10 goes with 1, 12 goes with 3, and 2 goes with 11. So for some of you, that might be kind of a difficult one to look at. If you want to be able to look at this picture and be able to set up the corresponding angles, which ones are alternate exterior angles, and so on. I just want to take a quick second and show you something kind of interesting. These two lines are definitely not parallel. But what I want to do is I want to ask the question, what happens when they do become parallel? Right? When they become parallel, something happens to some of our special angles. Well, actually, a really cool thing happens to all of them. So if you look at the top angle, this angle here, it's about 56 degrees. Now when this one is not parallel to it, let's measure it. I put my protractor in place, and now I'm going to measure this angle down here that corresponds, and it's more like, let's get this lined up correctly, it's more like about 66 degrees. So those two corresponding angles are not congruent. Now let me move it into place so that it kind of looks like it's parallel, right? And so I got my protractor set up. Let's measure that angle, that same corresponding angle, and see what happens. And lo and behold, it's a 56-degree angle. So when I take two lines and I make them parallel, some really cool, interesting things happen to um, our special angles. So let's discover this. Or let me just state what the relationships are, and then that should allow us to start setting up equations. One of the I can statements that we have to do is, given parallel lines, be able to write equations and things like that and find for missing angles. So let's go ahead and fill in that information. The relationship would be the name, and then the property is what I'm going to state it in just a second. So go ahead and see if you can write down the relationship name. It's one of our special angle names. Okay, so this is what we find out about alternate interior angles, is the property is alternate interior angles become congruent when the lines are parallel. They're not necessarily congruent. Whenever I have two lines that are just like that and I draw a transversal, this angle right here is obviously not congruent to that one. Okay, let me make it even more obvious with some bigger, more, um, less close to being parallel lines. As you can see with these two lines, the blues are the alternate interior angles, and one is acute, or even close to being 90. The other one's by far an obtuse angle, so they're definitely not congruent. But when we have the lines that are parallel, then they're congruent. So on a problem like this, I would have to tell you the lines are parallel, or I'll have them marked with those arrows that we've talked about in the past. So for your notes, we're going to quickly go through these properties, and I'm just going to help you set up the equations. We don't really need to solve for the x. I'm just going to set up the equation. Okay, and that's how I'd express two alternate interior angles on parallel lines. They are equal because they're congruent. So I'd write that equation, just simply solve. Okay, go ahead and write in the relationship for this one, then I'll tell you what the property is. Okay, so hopefully you saw those as alternate exterior angles. So look at the property. I mean, if you look at this angle right here, first of all, the lines are parallel, okay? And so if you look at that angle right there and that angle right there, they're both obtuse angles. So my bet is that they're going to be congruent. And that's what we find out. And whenever the lines are parallel cut by a transversal, alternate exterior angles are always congruent. So that's the property we want. Let's write our equation. And we just simply solve for that x and then plug it in to get the angle measurement. All right, next up for this one, the relationship is consecutive angles. And what do you think about these? Do you think these two angles are congruent? One's obtuse and one's acute, so that immediately withdraws that idea. So what we actually find out is that they're supplementary. If you're not sure what the word supplementary is, and several of you have told me that when I ask you it, you need to pause right now and do something about that. Probably the best thing to solidify that in your brain is to simply go to Google, do the research on your own, and you will have that. But having me tell you, or you waiting for the answer on this, is just going to make it harder and longer for you to figure that out. So what would be the equation I write? Right? That would mean that they're supplementary. Let's take a look at the last one. And so we have corresponding angles, and they're congruent. Okay? So since they're congruent, easy equation. Okay, and there you have it. Next up is I can use special angle relationships to determine if lines are parallel. So I'm looking at these two angles, and there's no special name for those. They're not alternate exterior. One's interior, one's exterior. So there's no special name for that. Therefore, there's no special property. But I'm not giving up. Remember, you're trying to work on your problem-solving skills this year. And so if you gave up at this point, that would be a mistake. What I'm going to do is actually use vertical angles to get that one to be 54. Now I have a pair of consecutive interior angles, and I can ask myself, does the property of consecutive angles work here? And if I find that those two angles are supplementary, then we have parallel lines, right? Because let's see, 126 degrees plus 54. Yep, that equals 180 degrees. This is what I know. They don't look it, but these lines are parallel, so I'll mark them. How about these? Are these two lines parallel? Well, this is kind of a trick question. These two angles are vertical, but they've given information only on this one intersection here. There's no way for me to send information down to the other intersection. If I knew the lines were parallel, then I could do that, but I don't know that the lines are parallel. I'm trying to figure that out. So don't let this kind of problem fool you. If they've given me information for only one of the intersections, I'm done. All right, here's another one. What would x have to be to make the lines parallel? So we have, this is a special pair, right? These are alternate exterior angles, and through the properties that we stated earlier, these two need to be equal to each other for the lines to be parallel. So I'd simply solve that equation and then find out what x would have to be and plug it in, find out what the angles are to show that they're now parallel. Just a quick view of some real world problems. It says I can use special angle relationships to solve real world problems. So when you look at these problems, you can see where parallel lines actually play an important part in construction and just all kinds of things. That one drawing over here is actually the airport, and you're looking at different angles and see if they'd actually work for an airplane to turn. And maybe the corner is just too sharp, and they would have to re-engineer the airport. All right, so now we're at our try it problems, and these are try it and master them. These should be 100% answers for you. Okay, so let's take a look at the. I just expanded that one for you. It was kind of hard to read. So we're looking at that angle and that angle. And so I want you to do these problems. Now, in just a moment, you'll see a little bubble pop up. But down here in the bottom is a URL where I need you to submit your answers online. Okay? So go ahead and make sure you do that. There's also a survey question on there. And when you go to do that, I want you to know one of the survey questions says to select the color that I mentioned in this video. And the color I'm mentioning in this video is